Thank you so much for the introduction. So this panel is about the computing power and algorithms as foundation of AI. And it's I think, motivated mostly by what was called by Sutton the bitter lesson, so the fact that most of the things we have observed seems to be related to raw computation power, and we wanted to have this space to discuss how much this is true. So what matters between pure computation power, data, and actually thinking and designing algorithms on the tailored techniques for certain tasks. So we have with us three guests. So starting from near me, Igor Caron. So Igor Caron is the CEO and co-founder of Lighton, a French company that, let's say, provide ways of training huge models easily, let's say. And you also take care, when you have time, of Nuit Blanche, which is a blog about machine learning, when you have time. And also you are a co-organizer of the meeting, machine learning meetup in Paris, if I'm correct. Okay. Then we have Thomas Capel from Weight and Biases. So Thomas Capel is a machine learning engineer, and so you have done a lot of things. And you are mostly now in ML ops. And for people not aware, Weight and Biases is used by everybody, actually. It's really a very, very successful company for, yes, everyone, yeah, all my students, actually. And then we have Guillaume Wozinski, who is a deputy chief data scientist at the Swiss Data Science Center, which is a center jointly affiliated to EPFL and DTH, and whose mission is to provide expertise in machine learning, designing new algorithms, proper analysis, and in data analysis for across many application fields. And then our coach there is Tobias, and I let you introduce yourself. Or...
I can do that, yes. I'm professor of physics here at the University of Geneva.
Yeah, I'm into the computer science department of University of Geneva. So you can ask questions at any moment. I think and also online. And to start the discussion, I would say just to give us a sense of what are the practical issues of ML on deep learning in real life. I think you are very well placed to give us a sense of this. So can you maybe summarize a little bit what are your customers or users, what are their problems, what are the methods they want or they should use, what are the mistakes they make, and, just to give a sense of what is ML on deep learning in real life for real problems. Who want to take the...
Hello, everyone. Weights and Biases, just to put a picture, it's a company that's used by model creators and model practitioners in general. So we have a bunch of big customers training large language models right now. And yeah, they have the main pain points that you had already training big models before, but now they have extra pain points of evaluation and that these models are really, really big. So yeah, we help them keep traceability, all that. And so when the teams scale up, they can share that data efficiently across team members. So one of the things we see right now is that everyone wants to have their own ChatGPT. ChatGPT is this super cool LLM from OpenAI that basically solves more than what it was trained for. And people are worried about putting that data out there and sending queries to OpenAI in the United States. The private and sensitive company data ends up in servers that they don't trust. So what we see now, probably Igor can extend a little bit about this, but people are trying to get their own version of their tailored, smaller size, curated with their own data, ChatGPT version, starting from what we call foundational models. It's pretty pretentious, but so they fine tune. This is the algorithm that helps you align the models to your own needs on their own data. So they have this new model that it's only for them, that never leaves their data warehouse. And this is extremely complicated because it's compute intensive. Creating the data set is not as easy as it sounds. You can actually use ChatGPT or tools like that to create your own data set with your own data. And at the end, they have this model that they cannot even deploy because it's complicated to deploy these large language models in infrastructure that they don't even know how to maintain. So yeah, there are a lot of like pieces out there, like just training the model is one step, but then like you have to put that model into production. And as François said, this is called ML ops, like ML machine learning operations. So it's trying to put all the pieces together so you can have a pipeline that works and you can update, because that model you just train now, it's going to be kind of outdated, maybe if we say so, in a couple of months, and you will want to retrain it with your new freshly acquired data. So yeah, companies, probably I would hear about what people are doing around to get their own model here.
Yeah, I just noted that since the name foundation models comes out of Stanford, you were saying that Stanford people were pretentious. I kind of agree with you on this. Let me just say that at Lighton we get to be doing everything around the life cycle of LLMs for companies. What has been essentially coming out for the past 6 months now is exactly what was just said. Everyone wants to have their own LLM inside the company, and for only one reason, really. It's not because the data is going away. It's really because the know-how is going away when you're using an open API type of capability outside of your company. And therefore, a lot of people are realizing that just having these LLMs helping people in their day-to-day work essentially provides an X-ray vision of the whole company as it goes. And in a way, companies are now realizing that they need to have this type of infrastructure really inside the company per se. And as was pointed out, everything is kind of up in the air. That is, in effect, even the words lifecycle management of LLMs is kind of a new word in itself. There are a lot of different uncertainties with regard to what these models are capable of. There is the notion that somehow smaller ones are interesting. I'm not of that view, but in a way, it doesn't really matter. What matters is really what the client is really looking forward to on how to use it and so forth. So in a way, a lot of this new engineering is coming up to be up for grabs in a way, because there are many different ways to essentially service this type of needs that are being expressed by all these companies. And one more thing that is probably a little bit different than what we've seen before. In machine learning, we used to have a whole community around data science and so forth. I mean, we're all kind of coming out of these communities. What is a little bit different here is that those LMs are giving agents directly to workers in companies. And those workers don't need to be data science folks. They don't need to be engineers. And in a way, this is how the whole game changes. The type of tools that you need to design so that LMs can be used within companies need to be essentially designed for workers overall, as opposed to data engineers, MLOps folks, or data science folks. And so, in a way, it changes totally the type of way you need to essentially interact with those systems, because we, as data engineers, have been accustomed to dealing with those models, machine learning models, earlier in a certain way, whereas now we have a different type of interaction. We get a lot of data out of it, and we need to use that data to essentially make those models better and better within companies and so forth. So that's about it. I mean, you were asking whether or not I could talk about what our clients are doing wrong and everything. I mean, our clients are never doing anything wrong. So in a way, I don't think this is something I can answer. But there are definitely a lot of things that you probably have seen over at Weight and Biases. That is, in order to get to the level where you can get an LLM within a company, a lot of blood and tears comes out. And so one of the reasons some of these companies like Lighton exist is to essentially make sure that you don't go through this very intense phase that makes it very, very difficult. In a way, what has happened also is we used to be talking about LLMs at different NLP engineers or different data scientists within companies before December 2022. And so we're trying to convince them, birds are good models, LMs are better, so for whatever reasons. And then since ChatGPT, you have had really a shift in terms of attitude, where we're not talking to technical people anymore. We're getting CEOs to essentially say, my daughter is essentially doing her thesis with ChatGPT. How come I don't have that technology within my company? And so the CTOs have to respond to this in a way that we have never seen before. I mean, in a matter of 6 months, you have very large companies that are essentially trying to see to what extent generative AI is going to be fruitful for them. So it has been a very large shift. I mean, in a sense, ChatGPT has essentially unleashed this type of new wave of engineering within companies. And so we're glad that OpenAI exists for that reason. But in a way, as opposed to the very generic type of engineering that we see with data science and everything, the main people we're talking to are not engineers as a whole. And so that brings a whole different set of issues that we have never addressed before as machine learning engineers.
Let me just add, sorry, I'm just going to add something. It's from a company we are a company that sells services to OpenAI, to these customers building models. And for us, from a point of view, the market just like expanded massively because now we have these customers that you were saying that are not, before that, we were just selling this tool to ML engineers. And now we have software engineers that are not machine learning engineers that just want to put some AI on their piece of software. And like people, as you said, non-technical people that just want to ask questions about the data in the company. So from our point of view, it's like our market just got way, way bigger. We have customers that we weren't thinking about before. So these tools need to serve people that are non-technical and give value to them inside the companies.
So at the Stu's Data Science Center, I guess we are working with collaborators and partners who have a bit of a different profile, maybe different needs. So, I mean, I co-lead the team that is primarily collaborating with research teams at PFL, Zurich, and the Research Institute. But we also have a team that collaborates with industry. And we also have a team that works on open research data and data infrastructures. But what we see in a lot of our project is a broad diversity of needs in terms of volumes of data and in types of machine learning, AI, or data science problems and models to use. And obviously, the latest models and generative AI in particular is very relevant in some of the application, but there is a large need as well to be able to use data that comes out of experimental research, for example, and that comes in limited amounts. It doesn't necessarily mean that this data is not large, because it can be high dimensional, like in terms of the volume or the number of features that you have, but very often the number of repeats that you have or the number of patients that you have is going to be a bottleneck. And what is somehow sort of very important is to take into account prior knowledge, that is knowledge which is not necessarily in the data. So, I mean, I think I greatly enjoyed the talk of Michael Bronstein because, it gives a lot of ways to show how to incorporate in the architecture knowledge about the structure of what you're trying to model. Yeah, so I think this is what I can say for now. Maybe one what is the mistake that maybe our collaborators are making? This is a question that we're asking, is oftentimes to somehow underestimate the amount of discussion that can be useful to design a model that corresponds to a particular problem, and the diversity, underestimating the diversity of approaches that can be considered for a given problem.
Maybe following up on what you just said and the talk by Michael Bronstein, that not only algorithms and architecture are important, but the right combination of the two, which was important for the CNNs, for example. So if you were to put it into three chunks, right, the compute, the data, and the brain, and look, like nowadays, what is the relative importance of the three, and then also in the future? How do you see this evolving?
I would say that maybe it really depends on different kinds of situation. So in the sense that they all depend on each other. So if you, I mean, the brain is always needed, I would say, but somehow what's going to be determining the type of approach that you're using is, you know, the data, right? So if you have very large amount of data to make the most of the data, it's I mean, on problems that are not too simple, I think the compute will be necessary, and therefore will become a bottleneck. On the other hand, if the data is smaller, then, like, you know, either the data is a bottleneck, or maybe the models that you have to construct have to be more refined to be able to extract information from the data. I mean, also it depends when we talk about amount of data. There is the question of whether we talk about labeled data or unlabeled data, so I would say that they all depend on each other.
In terms of what comes first, I think these days compute power, specifically in LLM type of discussions, compute power is everything. There is a difference between two companies. One of them has access to supercomputers, and the other one who doesn't, which doesn't. And in a way, one essentially goes much farther than the second one, who basically does not have compute power. So in a way, and I think we get to see this with the crazy valuation that you see for NVIDIA, because everyone gets to be essentially buying their chips and everything. So, and the numbers that we're seeing are so large that they're even changing the way people are even valuing NVIDIA stocks. I mean, in a way, what we just saw recently was really something of a shock for the analysts that were looking at this type of things. So compute power seems to be essential. And in a way, we all yearn for a better algorithm. We all yearn for smaller models. We all yearn for better data so that we don't have to do all these computations. The very fascinating thing is we are still at the stage where any of these things have essentially been more than wishful thinking. And so since the Transformer paper of 2017 and the scaling laws that came out of OpenAI, those two things came out. We haven't really had any type of meaningful, impactful, specifically in NLM, paper coming out of academia that was essentially GPU starved, mostly because you cannot do a lot of these experiments to show certain things around what is happening in LLMs and everything. So in a way, if you don't have the compute power, be it in academia or in a private company, you're basically on the receiving end of the choices that are being made by these companies or whoever has this computing power. And it's very disheartening in the sense that we are all, as again, I'm saying this because it comes from the heart, we are all yearning to have small models, better data that doesn't require that much compute, better architecture so that we don't have to do this, those type of computations that are easily overwhelming supercomputers we have, especially in Europe and everything. So in a way, we are all looking forward to this, but this is not happening. We are not seeing any type of breakthrough in that regard. And I think one of the big bets that a lot of people are doing when they're buying 100,000 H100s, NVIDIAs, are essentially praying every day that no one is coming out with a breakthrough. I mean, we are all looking at it from the different standpoint right now. We're always saying, you know, oh, they have that many GPUs, they can do all these computes. But if you are on their side, you're at their position, you're basically in their frame of mind. There is someone who's going to be coming up with an algorithm that's going to be destroying this whole thing. And to a very large extent, it's a huge challenge that we have to essentially break through. But as of 2017, it still has not happened yet. So compute is everything in LLM, and then eventually data. One of the things that I used to be, when we were starting in LLMs, I used to be asking my engineers, you know, should we take like Rousseau or Voltaire or Camus and just be done with it for the French? And the answer from the engineers was like, no, Igor, you didn't get what I said. We want the whole civilization. So in a way, we are not accustomed to this type of discussions, really. And obviously, there are a lot of different discussions in society about all these things. But in a way, in order for those LLMs, to me, and this is more like an idea than anything, reflects more us. Those LLMs are a reflection of us. They're a reflection of our civilization somehow. And if you're not contributing your data to it, maybe that in the future, your civilization will not count as much. And so there are different discussions that we need to be having if there is no breakthrough somehow on the computer or everything, about what we need to have in those LLMs so that eventually it represents us. And us could be a country, it could be a region, it could be several countries, it could be anything.
I think there are two questions in the room. No, you
have the micro.
Perfect, thanks. Daniel Dobosch, Research Director from Swisscom. Thanks a lot, really interesting discussion, and I can agree to almost everything that you said, so I don't want to repeat. One question that I would have is, you know, you had the question, so what have clients did wrong? Let me rephrase it. What can do clients of the future do better? And there, I think you have mentioned a lot of important aspects of data, and one could argue that, you know, there's a huge spectrum how companies and organizations in general are prepared with their data. Some basically, you know, have started to reorganize their data years ago and are now ready with their data. Some basically have to do that exercise right now. Same with the brain and hardware, you mentioned that. Some of them have basically bought the necessary computing power before, some not. But one thing that I'm still missing in this discussion is how they can prepare it, and this is the aspect of trust and security. Because this is also what we see basically, that you mentioned that data should not go outside of Europe and Switzerland, where so even we're thinking of data should not leave Switzerland. I haven't heard anybody thinking of, you know, going from data from one canton to the other canton, but maybe this also can happen, I don't know. But trust and security, this is really at the starting. So yes, everybody talks about AI red teaming and nobody knows how to do it. Everybody thinks about, you know, how can we transfer the learnings that we have done in cybersecurity the last years? How can we transfer this to AI models? Do you have any thinking about, you know, how can clients of today be better prepared for these challenges in the next years?
Go ahead. So I used to be working in aerospace before, where red teaming comes from, in a way, from NASA and everything. When we were sending things into space, we had the red team. We had people that were coming in, and they were like nothing else, as in, oh, this guy has done some flights. Oh, this guy, I don't know, but he's the one that's the harshest with us and everything. And they come up with like stupid questions, you know, and we get to answer them, and they're like, no, that's not going to fly. Your stuff, it's going to take 3 months before it goes back into the manifest and go back into space and everything. So in a way, what I'm trying to say here is ChatGPT is December 2022. Today is September 2023. There is some amount of time for all organizations to essentially come up with ways to deal with this. It's not going to be up and coming right away ready. I think it's going to be something that's going to be built over time. We're going to see a lot of different mishaps somehow. And those things will have to be dealt with within companies. There is a whole lot of different engineering that's be coming out of these questions. And in a way, what I'm seeing right now is the beginning of people realizing that it's not just in one country or the other, it's one company as opposed to the other type of things. So there are going to be jobs around these things where you're going to be red teaming. The trust issue, in a way, a lot of the data that will be produced will be inside the company. That is, people will essentially produce text, produce voice and everything. It will be used for the company to essentially focus on whatever it wants to do and everything. A lot of the trust issues that you're talking about are already something that we have within our normal companies these days. There will be a segment that is attached to LLM related type of activities in the future. So in a way, what I'm trying to say here is, I think there are issues and they need to be looked into from the legal and other standpoints. Having an answer now, I don't think we are ready for this. This is a science that is essentially taking shape as we speak.
I just want to add that, you mentioned that, companies that are getting thousands of GPUs have the edge over the ones that don't. I don't, that's true, but I don't think everyone should be going and buying GPUs for the companies. Like, I do a lot of work in the open source community, and we have seen people already taking these big models with super efficient algorithms and aligning them pretty well. And it's really, really cheap. Like for a couple of $100, you can get a Llama state-of-the-art model aligned to your data needs inside your company. Or Falcon. I prefer Llama, but and that's something that probably companies are going to do. Or you can actually get GPT 3.5, the OpenAI model, trained on your data, 10,000 examples, and you get a pretty good model already, and it's cost you like $60-$70 right now. So for creating those foundational models that you will be then aligning to your data, you will need 1,000 GPUs and probably, we all thrive for a more efficient transformer algorithm or a new architecture. But I think a lot of companies right now can pass through consulting firms or companies that are specialized in building and aligning the models to your data, get their own model pretty much right now. And that's something that, you have to take into consideration if you want to start using the powers of stuff like ChatGPT inside your company data.
If they speak English.
If they speak English. I don't know. Or code or math or...
We're in a country where there are 4 different languages. I don't think there is an LLM that goes for the 4th language that I never remember that you guys have here.
It's true that the models are biased in English, but I think curating better multilingual data set is something that, we have seen some open source community doing it. Hugging Face have been pushing a lot of these events of fine tuning. There's not as big as these models right now, but BERT and all those smaller transformer models have already been fine tuned in pretty large language data sets in multiple European languages. And I am not aware exactly on everything that's happening in Asia, but I know that Japan and Korea have pretty good LLMs already. So I think there's still a lot of work to be done. But curating this big data set, I always hear people saying, curating a super huge 1 trillion data set. Data set that measuring tokens. Tokens are like small snippets of words. You can think them as sellouts. And 1 trillion, it's a lot. And this is what Llama was trained on, more than 1 trillion tokens. We don't exactly know for OpenAI. But we have seen the open source community curate this data set in a couple of months. The pile, that's a data set that was curated by Eluther AI. Eluther AI is probably the biggest open source effort out there to put this GPT-like models. They curated a super big data set that is not extremely high quality, but it's already really, really, really big. And probably more efforts like this will come in the next months. So I don't know. I think there's a lot of work being done by the open source community that at least we should follow if you don't want to be like locked on a vendor or on a type of model.
Okay, thank you. Another question. Guillaume?
Maybe to sort of follow on this question of data and maybe to answer some of the questions that have been asked. So I mean, maybe if I take two aspects of your question, the one that first that connects with what we were talking about, which is sort of related to data curation. I mean, one of the things that we noticed in particular with our industrial collaborators is that, but not only. I mean, the same question arises with, I think, overall all of our collaborators, is to have a stronger data infrastructure, in the sense that many people have data, and sometimes like data that is extremely interesting, but the way the data is accessible and maintained is key to be able to do something with it, especially as time passes by. And so like all these questions of data traceability and the metadata, which is often like whose role is often underestimated, is an issue that we see coming over and over. Now another question that you were mentioning was the aspect of security, but also I understand that you alluded to the possibility of somehow exchanging data or having a way to like exchange or leverage data that different people have. And I mean, this is obviously a very interesting question. So I think there's a number of things that can be said there. I mean, the first is that one way that potentially large models and compute can be useful there is via creating static data. Because like, if from your data, you're able to create synthetic data that somehow capture a number of characteristics of the data, but without being exactly your data that maybe you cannot share, then this is something that can be interesting. And of course, there's a number of, techniques to be able to work with data without sharing it, such as differential privacy. But not only. So, I mean, one of the topics on which the Swiss Data Science Center is putting an effort is on the activity of a small group at SDSC, which is working on what we call the data custodian, and whose goal is to try and work on setups where different partners can put in common resources without having access to each other's data, but sort of use algorithms in common or use byproduct of the algorithm that are not sharing data that you don't want to share. And so I think this is something that is quite interesting.
Yeah. So before the question, maybe one last comment is that from my experience with industrial partners, if you think you have data on everything, you're probably wrong. Every time they say, "Oh, but we have data," everything is they are wrong. So you really have. There is a strong mistake that everybody is doing is that they think they have the data, and they don't have the data. And really, it's crazy. It's like with probability 99%, they say, "Oh, don't worry, no, we have the other don't, but we do." No, they don't. It's a bunch of Excel files with not the numbers everywhere. So really, you can't overestimate the value of taking care of your data properly. So there was a question.
So I wanted to ask about data. So Michael Bronstein, the previous speaker. Basically everybody laments about the lack of compute, right? And if you look at it, we have GPUs for what, 25 years and transformer architectures, 6-7 years. Somehow we are in a comfort zone and everybody uses transformers because they are more or less universal architectures and the computer is there, right? And maybe you just need the right compute scale I would argue that, and probably it's not only me, many people would agree, data is way more important than the first two, than the architecture or the software and the hardware architecture. And if you mention ChatGPT, if you look actually at the credits, not the list of authors, but the credits of the ChatGPT paper, I think the bulk goes to data curations. But I don't think that they disclose how much they spend on curating the data, but probably it will be an order of magnitude more than what they spent on the compute. So people are shocked by multi-million price for the GPUs, but probably it's in the tens of millions, if not hundreds, on the data curation, especially with the reinforcement learning that they use. But there are other fields where the situation is very different. And I think one good example is chemistry and biology, where data is scarce, orders of magnitude scarce, and expensive. So it comes from chemical experiments. Even with the most recent and future high throughput technologies for doing chemistry and biology, there is no way that we'll get anywhere close. So can you comment on that? So, well, Yom, you mentioned the federated learnings. A lot of data resides, for example, with pharma companies. They are reluctant to share it. So would you see a future where this is done somehow, for example, using cryptographic technologies and federated learning? And what would be a successor to Transformer in these data scarce region? And maybe a successor to GPU. Well, I'm not sure it will be the photonics chips that you're developing. I think that's, well, as cool as the idea is. Maybe it's a bit too exotic, but maybe something that is a variation of the GPUs.
Thank you. I think I think those are really interesting questions. So I'd start with the first one. I think like the second one on what is coming next after the transformer to address these issues. I think it's a very difficult question, but I think so. The SDSC is involved. So we're working in a project with the 5 university hospitals in Switzerland to try and pool data together. To put in place what the SPHN calls national data stream, and this is extremely difficult. So to, as you say, even somehow within the public domain, to have different hospital agree on legal terms on how to share data and which data to share. I mean, it took us something like almost a year to have a consortium agreement that everybody is signing. And so definitely we'll have to have ways of sharing data without sharing data. And so the different ways of tackling this are different techniques, from either differential privacy, but there is also a technique like homomorphic encryption, which consists in this is technology that allows you to somehow take data, encrypt it in such a way that you can then share it without revealing what the data is, but then you can on top of that you can do computation on this encrypted data. It's been shown that you can, people have implemented deep learning. This is increasing quite significantly the amount of compute that you have to do, even though there's significant effort in reducing this compute. But it's possible to be training on this data that is encrypted and then to only decrypt the final result. Other techniques include multi-party computing. This is very interesting. So those are techniques where each member of a group of partners who would like to somehow put data in common without sharing data are injecting noise in their data, but in a particular way, which makes it that once the computation is done, somehow the noise can be used to create, I would say, destructive interferences, so that the noise that was injected at the beginning can actually be removed at the end of the computation. So the noise that is used is of very large magnitude, so that whenever you share data on which you have added noise, it's impossible to actually read the data which is under noise, but then in a number of settings you can remove it. So I think it's a combination of different solutions which need to be put in place, and I think it's very difficult to decide ahead of time what what is going to be the solution. Yeah.
Yeah, I think you mentioned very important point. So I just wanted to clarify. So about technologies, cryptographic technologies like homomorphic encryption. Do you think that the current situation with generative models potentially puts it under a big question mark, because your ability to train a model on encrypted data, well, basically producing weights without seeing the data, guaranteeing with homomorphic encryption that your operations on encrypted data are equivalent to on the plain text. Because when you train a generative model, there is a risk that it regurgitates the data on which it was trained, even if you have never seen the data. So it's somehow hidden in the weights of the model. So if I'm a pharma company and I have my super secret compounds that I'm sharing with you, in the hope that it will be used to train a model, then somebody can just make the model produce these compounds that the pharma wants, the pharma company, the last thing it wants is for somebody to see, right? So do you think it's potentially a showstopper?
Thank you. I think this is an amazing question. I mean, this is part of the concerns I have about static data generation. I think we don't have the answer, and unfortunately, I'm not sure that we'll be able anytime soon to provide guarantees with these like purely data-driven techniques that the synthetic data that is produced doesn't have in common particular features that you would be able to reverse engineer or to extract, and that would be able to it would actually leak out information. So it's going to be extremely, I think, important. I mean, for people who are interested in these questions, to compare essentially what they can get out of different technologies. And one alternative is to be working with, for example, use techniques of differential privacy, right? And I think if you use your data, but like it's actually being the principle of differential privacy is to sort of modify your data by adding noise in such a way that it's impossible, and it can be proven. I mean, like there's a theoretical proof that from an information theory point of view, it's not possible to reconstruct your data or even infer properties of your data that you wouldn't want people to infer. So I think it'll be very important to consider these different technologies, and based on the problem considered, to find what is the best trade-off between perhaps like synthetic data generation that will come with less guarantees, but which maybe might create data that will have good properties from a learning point of view, and maybe other techniques that come with stronger guarantees, but maybe might be a little more difficult to put in place, and might actually have a cost in terms of performance.
Well, at Triton, we are not doing photonic hardware any longer. And so to be clear, we used to be doing this. And so it was a great introduction into this whole area of LLM eventually. But the thing of it is, to come back to your question, we see different modalities being taken up by those LLMs. One of the things that we did over at Triton was, and we open source those models. We did evaluate those scaling laws for proteins, essentially trying to figure out exactly if you could figure out what was coming up given a certain sequence and everything. And what we showed was really that they were following those scaling laws. And so I'm coming back to you essentially saying, please have another algorithm and everything. And I'm telling you, no. In the data we saw at 1.5 billion paramount moles, and lower, we could see that the scaling laws were essentially holding up. And I think since then, because that work is about prehistoric, like about a year and a half ago, I think a lot of people have essentially got onto that thing and gotten larger models and everything. So in a way, whenever you see that the scaling laws hold, the next best thing for researchers is to go for bigger things. So you go for this. What we also found out specifically in the bio sphere, was really that the data was really not just important, but a lot of it was not of high quality, let's say. And so a lot of the work that we did was trying to make sure that when we were talking to the good folks that were doing the study with us at Oxford and Harvard, that we would be getting the right data sets in order to basically pick up the right ones and everything. And even then, we had to make choices about which ones to include and everything, because there is an overrepresentation of certain types of DNA as opposed to others for disease purposes and everything. So in a way, there is the bias that society puts into the research that shows up in the data set. And that's probably not the one you want. And so that's why it's kind of rare and everything. So, but in a way, it's still biology. So in a way, if those moles are holding, you know that if you have more data, and in the biosphere, you basically have more data because of the sequencers that are doing a great job these days and everything. So, you know, in a way, what I'm trying to say here is, I agree with you that data is second to none. I mean, after compute. But in a way, what we've seen in the little sphere that we were into for a little while, if you're following the scaling laws, it really just yearn for bigger moles. And so that's the next thing that you have to do. Now for chemistry, I think what I've seen in that space and what I think is coming up in engineering as well is now the fact that you're going to be finding, let's say, the new compound or something. I think what's going to be coming out are moles that are text-based. They're going to be using a lot of English text. They're going to be using some nomenclature for, let's say, chemical type of components. And you're going to get database from compounds and everything. But what I think we're going to be discovering is, specifically in chemistry, which to me is still kind of a black art, the fact that we're going to be discovering things, as in we're going to be discovering processes that have been embedded in the way we've been doing things and the way we essentially tell the story on how they're being done now, are probably going to be the key for us to figure out other processes out of this. So it's not going to be a one way, a direct way of saying, oh, this compound is going to be better because we have those and we can continue this one to be going to this one and this one is going to be curing cancer and everything. I think we're going to be figuring out with some of the LLMs that we have is really that some of the engineering processes that are taking place in chemistry at different scales are going to be unfolded and somehow rediscovered, because we're now going to have an LLM that's going to be able to help us into dissecting those processes. So this is kind of my hope, but you know, I just don't know that much about chemistry as much as other people. But for the bio thing, if it follows the scaling laws, you need to go to the bigger moles. Or you need to find this other transformer plus that we still haven't found. Coming back to the initial statement, you know, we are all yearning for models that are not requiring supercomputers to essentially be trained. Right now, we don't have the luxury of having those.
So maybe there is a question. Maybe one follow-up question, and then we go to the home is because it's underlying a little bit the discussion, and I think it's reality. So with of course LLMs, but also models like CLIP, there's obviously a transferability and an ability of taking advantage of zero-shot learning and pure-shot learning, which is really impressive. So with CLIP, for instance, so CLIP, for people not aware, it's again OpenAI. It's a model that allows to attach textual description to images, and then you can do zero-shot learning with that example by describing the type of stuff you want to recognize. So you can say a red flower with green leaf, and even though this very object never appeared in the data set. The different element can be combined by the model to understand what would be the graphical representation that would fit this description. Is it an illusion? Underlying there is enthusiasm of people for LLMs, maybe a bit oversized because they think it may solve many problems. But is it true or not that this kind of techniques start to close the gap? So now, even though the LLMs or those models needs a lot of data to be trained, when they are trained, they start to come on the territory which historically was more designing algorithms for in the low data regime, which has the right inductive bias because you are really designing them specifically for a task. Is it something that already is attacked by the LLMs on these large models? They can start to solve those problems. And do we think it's the future? So that indeed a lot of problems traditionally in the low data regime where you need humans thinking about designing the model will be solved by those more general models, which have seen a lot of things. If my question makes no sense, don't hesitate to.
Yeah, I mean, maybe one way to think of your question, which maybe is different than the way you formulate it, is that, I mean, to me, very clearly, there's a number of types of data for which we're able to do very well, either using models that are pre-trained on large corpuses of data, and that allows large architecture to do representation learning and capture some learning bias, which is important for all the problems that are going to be using this data. So I would say that, like, even if we don't go to zero-shot learning or meta learning, even with like just a simple idea of pre-training, like for both in NLP and for images as like stereotypical examples, we have ways of like obtaining like more efficiently results with limited amount of data by benefiting indirectly from large amount of data that we use to train these original models. And definitely, I think that with the development of zero-shot learning and meta learning, we'll see an increased possibility that if you have only a limited amount of data that is at your disposal, but somehow you can benefit from what has been extracted from similar data, this will allow you to speed up the training on your data. Now, I think one of the questions which is difficult is, to which extent we're able to extend that to other domains than the one that we know. I think, the question on how to do this in chemistry is a very interesting question. And I mean, somehow, in cases where large amount of data are somehow like publicly available, and the problem probably is going, there's going to be faster progress in doing this. When the data is actually sort of collectively produced by a large number of entities who are not incentivized to share it, it's going to be much more complicated. And then, so the question of how to share this data is going to have to find different solutions depending on what is the reason not to share this data. If the reason not to share the data is primarily privacy issues, then there's a number of solutions. If the problem is in the value that you can actually extract from that data and the knowledge that you can gain from it, then this is a different problem, because essentially, then somehow it makes it more difficult to share it.
I'd like to come back to a previous statement I made about computing power being first and foremost important. One of the reasons computing power is important is not because you can train a very large model. It's because you can get PhD level students, grad students, to be playing with different models and find out exactly where the comfort zone is. There is this paper that just came out. I saw this on Twitter from microsite that says, with about 1.3 billion pound mole, you can essentially get to have some sort of emerging capabilities with regard to writing code and so forth. And what I see in that paper is really that you need about, 20 epochs that is, you take the data and you essentially use it about 20 times to learn your algorithm on something that is pretty small, 1 billion pound mole. And what I'm trying to point out when I'm saying that you need compute is really that the scaling laws are allowing you to essentially project on the 1 billion to the 100 or 200 billion mole. That's one thing. But there is this effect of, if you do not have the right type of people in front of these compute, you basically are not exploring the whole phase space of what is feasible. One of the reasons we are not finding better algorithm is because we don't have grad students having access to supercomputing facilities in Europe or anywhere else. So it's not a question of having it for the purpose of doing one of these large language models. It's also for the purpose of doing a lot of different training, different experiments. When we do build those large language models, a fair amount of our compute is basically done on small models to figure out if data distribution, different type of evaluation eventually get us to the right stage and everything. So in a way, data comes back into the discussion, but if you do not have the compute, the data is essentially useless. But if you do have the compute, data comes second, and it's basically to try different things so that eventually you do not have to build the very large language model. And the one that everybody's yearning for, which is the small model that can do everything, which has still not happened yet.
Yeah, that's exactly something I see in the open source community. People are trying to play with gaming GPUs and trying to scale as much as they can on these. They're not cheap, but $2,000 per GPU, building their own rigs and trying to scale this, as you said, 1 billion parameter model seems to be the sweet spot. If you scale down, you don't get the same scaling loss. Like I have played with 110, 500 million parameters. And if you want to get something reasonable and that you can extrapolate, you need 1 billion. And for 1 billion, you need basically 8 big GPUs. And that's nowhere to be found right now. I just want to add something about what you were talking about, specialized small models that are going to be replaced with single shot or zero shot learning. That means you inject the data on your prompt and you ask your data, your model, your LLM about the data. And I think probably yes, because you will see people that were not able to do those queries. Just a quick example. You have your company, we have a lot of customers' data. We store everything on a SQL big query database. And not everyone knows how to do these queries. Like SQL is kind of tricky, and then you need to aggregate and then create a plot that looks nice. And of course, this could be done by something that experienced with that and maybe some SQL and putting that into, I don't know, R or Pandas and then formatting the data somehow and showcasing the results, like how many customers did that on that day and whatever. Right now, you can just do that with an LLM. So a lot of people that were not able to have that data will be able to not just get one query in one day, they will just explore the space. Oh, what happened if we cross that data with that one? And maybe put me that together, create me a plot for that. Oh no, replace the axis now. And all that in common language with the LLM creating and calling the right tools, because right now where we are having is these LLMs that can then connect with SQL and with another plotting tool. So they're combining the tools themselves and replacing something that was used to be done with no machine learning actually. And now it's being used with an API or with a model on a service. So yeah, some of these tools will be replaced, I think, and will give you more iteration power inside your company.
Yeah, that's what we were saying originally. That is, you essentially give much more agency to many more people within the company. And so a lot of the very interesting ways of finding out new molecules or whatever, new processes, will end up being much more driven by the number of people who will have their say in finding those, as opposed to having this data scientist that knows everything or the prompt engineer that knows everything. It's going to be every one of us. And in a way, in large companies, what we're going to be seeing is the leveraging of these large companies with large amount of people working in them, and all of them having sort of a way to seek out the right type of applications or the right type of algorithm. I was at a meeting over in Munich about a few days ago. There was these folks from IBM talking about their new platform. They essentially asked their 100,000 people within the company to try things out with the platform, to build new apps. And they got in about a day about 20,000 apps, which are probably kind of similar for most of them, but they're all in different, potentially different sub-companies or different countries and everything. They do different things because they are locals and everything. So there is this richness that comes out of these essentially models that talks to everyone and lets everyone to be more creative.
I can feel a political undertone forward to the people. There are questions in the room. I don't know. We have collision of questions.
Okay.
First on this side.
All right. So maybe this is a kind of a follow-up question on the trust question that was asked before. It's about validation. So say you train an LLM model for a particular customer, and how is that model validated, and how do the customers make sure they can trust the model, that the model is, say, not hallucinating too much, and that they ultimately take advantage of all the computing power that was into training the model?
I think that's a difficult question. So I think you're asking two questions that I think are difficult. The question of I mean, this is, I think, one of the difficulties that research in the area of large language models will have to address in the future. And as we see that this is moving extremely quickly, right? Which is to find ways of identifying when the model is indeed hallucinating and to correct that. Are we anywhere close to providing guarantees that it hasn't? I mean, I think it's going to be possible in a number of cases to add mechanisms to perhaps verify some statements that are made by large language models. I think what is going to be more difficult is something like the lack of identification of something which is true or knowledge that is there, and that the LLM will have hallucinated, does not exist, or is not an appropriate answer to the query. I think this is difficult, but at the same time, this is something which, no matter how complex those systems are, will always be a problem. I think ourselves, we fail at some point in this task. And then the second question that you're asking is, if you're working with a particular customer and they provide new data, and so if you are fine-tuning, for example, the architecture, or you're simply using the LLMs to create value, can you quantify how well or guarantee that the code that you've been running has actually extracted significant or relevant information from that particular customer? I think this is a great question, and I think this is a difficult question, so I don't have an answer to that.
So we have some of our customers build their own models. We also have Paradigm, which is this software that essentially allows people to deal with the life cycle of those LLMs. That is, once they're there, they now need to be in production within the company and tested and so forth. In a way, you don't get clients that are building models just because it looks good. They have either a need of different kind, but they have a need. And therefore, they have an idea of what the evaluation pipeline is going to be, or at least they're going to have to make one out because somehow you're doing something for them and they have to figure out whether or not you produce something of value to them. So in a way, there is this first level of defense that you have as a customer trying to figure out whether or not you're coming out with something that is potentially, at the very least, initially useful to you. And then eventually, it all comes down to how it's used within the company, how people within the company or outside the company are going to be interacting with it. And so somehow you need to have tools to essentially record all this. You need to basically be able to figure out the positive and the negative examples. And then you need to have different campaigns on doing RNHF fine-tuning or essentially do a combination of fine-tuning plus adding some sort of retrieval type of capabilities so that you know that it's much more grounded in new things coming up or older things that were not part of the data set that was used for the LM in the first place. So in a way, as I said, once these LMs are inside the company, they become alive. That means essentially you need to deal with the whole, you need to have tools to deal with the production of data from this LM, and you need to essentially make sure that it is useful so that the second, third, fourth generation of LM within the company are useful for different business users. And as I said a little bit earlier, the agency of everyone means really that it can be used for marketing, all the way to engineering, all the way down to payroll. So in a way, these things need to be looked at because somehow you don't want to have errors. And so that's part of the process of getting this technology to be sticking within the company. Yeah.
Let me add something here. We built a small tool like a couple months ago, like for Insight project on our company, because we want to figure out how our customers are like using these LLMs. And we have a Discord channel. Discord is like this open community where you can talk with more people. And we get a lot of technical questions in there. So we built a chatbot that knows how to use our product. And we didn't know how to do it. So we kind of figured out that we put all our documentations, all our code base, all our examples, we curated them, and then we didn't train, but we used OpenAI basically and embedded all that data and somehow with a retriever system that will, when a user asks a question, it will find out in the documentation the relevant parts that could maybe potentially answer the question, and then stack everything together somehow in the LLM, so the LLM can produce an answer to that. And we quickly realized that we need to keep track of the answers the LLM was giving. And we, as you said, we put a vote system. So we, the engineers, could vote up or down when the LLM was doing wrongly. Then we set up a dashboard that we could evaluate like, okay, we have created now 1,000 answers, how good the model is doing. 70% of them are being accepted. Then we realized maybe we need to replace this ChatGPT with some fine tune in our data, but we need to create that data set. So we used that models also to create synthetic data. So we ended up like figuring out that, yeah, you need a lot of traceability and debugging this is pretty complicated because maybe the LLM is not the issue and it's the retrieval system that when you search your database, because you want to give answers that have sources like, hey, this question you ask about how, I don't know, how is the weather here? The source for this answer comes from this, and it's not an hallucination of the LLM. It's actually data that's being parsed. So yeah, there's a lot of like pipeline steps we need to keep track. And as we are being customers of our own product, build more steps on like, oh, we need maybe to keep track of the prompt and maybe of the retrieval and the database. As you said, like the data of the database, because is it updated with our latest product, that question and asking questions in the Discord. So I encourage you to check. We can discuss afterwards if you want. If you are more interested, I can give you the link. Everything is open source, so you can reproduce that in your own organization. But it's actually multiple steps, and the LLM is just one bit, and all the other parts are complicated.
Thanks. This is all very interesting to hear from people who are at the coalface training big machines and things. But I wanted to connect a little bit to what we were talking about yesterday around areas to do with LLM governance or oversight or safety or something like that. So just imagine that there was a need for a rule that says if you have an LLM, then you should do this, or it should have this property, it should have this provenance mechanism attached to it, or maybe watermarking or whatever the rule is. It would be relatively easy to enforce that rule for the large companies, but there's an issue with open source LLMs. It gets harder to enforce those things. And it just occurred to me that the organizations that you're in are very well placed to deal with, to be an entry point for legislation around a certain sort of LLM where you're doing fine-tuning services. And I'm guessing a lot of people, if they're not the big companies, will be running through a service company of the sort that you're doing. There's machine learning ops or compute services or something like that. So I wanted you to comment on whether you think you'd be a good point where legislation around LLM safety could land outside of the big companies.
One of my motto is if you don't pay attention to politicians, the politicians will eventually pay attention to you. I think this issue of safety and governance is a normal one, an obvious one. In the context of legislation, we see a lot of, in Europe, in my mind, Switzerland is part of Europe. I mean, the thing of it is, we have had, let's say, policy decisions or would-be policy decisions that are coming about that are driven by elections for the European Union next year. ChatGPT came out in December when they were drafting the AI Act. And in a way, I think it took them by surprise, even though the LLM story was an old one at that point. And so a lot of the, let's say, discussions that came out of in the European Parliament, but also other stakeholders in the trilogue that is about to take place in Europe, have been somehow moved into taking positions, I think, in a manner that is probably hasty. And so, in a way, I don't think people have realized somehow the importance of thinking this through, or at least for some of the discussions that are going on at the European Parliament. I think being a French company, a European company first, we get to see a lot of activities around this where we know that somehow some of our, as a startup company that is kind of small compared to the big ones over in the US and China, we get to see a lot of interest in those very in this subject area. When in fact, what we see in the type of customers that we're dealing with are not the type of issues that they're concerned about, yet those subjects are being commingled into one subject area. And so a lot of the things that we see out of the European AI Act, for instance, currently being spoken, being looked into, talk about having to have software that need to go through a lot of different, how can I say this, layers before getting to market. I don't think people realize that bird molds, that is in effect the ones that were just before LLMs, are of the same kinds as the LLMs that we are building. And in a way, people don't realize that somehow, if we are putting birds in the same category as LLMs, a lot of the NLP activities in Europe essentially goes to a standstill. I don't think people realize how much effect it will have on the overall economy here. Let me put it this way. I think there is a lot of discussions that is not driven by what we know of these models. There is no pragmatic way of looking at what is essentially unfolding in front of us. And I fear that's how a lot of decision making will be made the wrong direction if we are not having a say on this. And as a small startup in Paris, we don't get to have that much of a say. There are very few of us in Europe, probably a few in Germany, a few in France. We don't get to be heard that much. What we see is a lot of representation from the US in think tanks and so forth about this type of issues. And so somehow I think there is an issue of sovereignty and economic growth in Europe that is not being addressed by these concerns that may be true or maybe not true. But in effect, we cannot have the type of words that I'm hearing from the European Parliament as is going forward. Otherwise, we're essentially not going to be growing our economy in the same pace as the rest of the world.
We have a few more questions in the room. Over there. Oh, over there. And then next here. We have to have short responses because we're running out of time.
François Gray, University of Geneva. I sense a lot of the discussions are around issues related to privacy and scarcity, privacy of data and scarcity of compute power. What role do open solutions, open source, open data, open access to computing power, what could they play in the future, especially for science applications? We have organizations like CERN and NASA pushing an open science agenda. How much is that going to impact things?
Let me answer this. I don't think there is an effect. To be clear, open science or not open science may be good for essentially knowing more about this algorithm and everything. What we currently see nowadays is whether or not you have access to compute or not. Currently in Europe, LLMs are not seen as one of the categories under which you can essentially push a lot of proposals at the level of Euro HPC, for instance. So a lot of activities that is going on currently in the HPC in Europe goes around essentially the notion that you can run model for about 20 hours and essentially get back into the queue type of things, like what has been done in HPCs. The type of workloads that we have takes 6 months. It's all thousands of GPUs. So this is not negotiable. So in a way, if there is an open science type of things, it ought to be following a little bit some of the constraints that we're seeing in LLMs. And as far as I can see, none of the leadership in the European Commission has really understood really the constraints that we are seeing in order to be competitive with regard to the rest of the world.
Let me just add extra. We have a lot of users in France, and a lot of research institutes use the Jancé hypercomputer. And a lot of people contact us like, we need to help them resume training after the 24 hours kickoff. And we have been doing I have a meeting next week to help them like, hey, we were kicked out and we need to find a way that weights biases helps us out, like to resume exactly where we were because it crashed. And yeah, as you said, like leave it 24 hours. Yeah, you cannot do that much.
I'd like to give an answer perhaps more on the data side. I think there's a number of domains where indeed there's a lack of progress because of the lack of sharing of data, because sharing data or sharing byproduct of what you've obtained in research is very difficult. And so I think this is a place where open research data and efforts to create hubs of data could actually be very useful.
Probably the last question.
Okay, so I'm hesitating to ask you the last question. So we hear about speaking about algorithms and computing power, and I hear clearly we need more, but it's also more cooling is needed. So data centers need to be cooling. And now there is this thing called sustainable AI, not AI for sustainability, but really, if you look also what the studies comes out from Stanford or from Microsoft, how much large the CO2 footprints are to develop these large language models, to deploy them. So I have a little bit open question, how you communicate to your different stakeholders to do it responsibly with having like a sustainable AI idea in head, or because society on one hand, they ask to be more restricted by using energy. And then on the other hand, they see such things going. So there's some societal this mismatch between what I feel in your panel, we need more computing power, and on the other hand, with stakeholder like the society.
So maybe there is, thank you for this question. I think there is one topic that we really didn't develop in this conversation is frugal AI, but this is a reality. And there is a number of things that, thanks to techniques from machine learning and AI, we can, actually decrease the cost of certain things. So for example, at DSDLC, we're collaborating with people working with large, climate and weather models. That are actually very compute intensive. And they're very, very compute intensive because large parts of them, not because, but it turns out that large parts of these are actually solving partial differential equations or actually like making like very heavy calculation from physics. And we're able to replace a number of these elements by surrogate models that are trained with machine learning that allow like very significant speed ups. There's also a number of areas where we can help people that have massive amount of data that is takes a lot of space to actually transform that data and encode it in such a way that preserves the information that this data contains, while achieving two goals at the same time, sort of extracting part of the information of the data and reducing significantly the quantity of data that needs to be stored and manipulated and computed. So, this is also a place where we contribute.
Thank you for the question. It's definitely an interesting one. I think I have two views on this, and those are more personal than anything else. So I'm not quite sure they are the company's one. The first one is, you have to have a supercomputer or whatever compute in a country that does not produce as much CO2 as the rest of the world. So France is a good example because of its nuclear fleet. And so therefore you should be doing your computation in France if you have the ability to do so. So that would be the first thing, or Sweden, or Norway, or Quebec, or any of these places where the amount of CO2 is essentially the lowest there is per kilowatt hours. So that's one thing. But this is kind of the defensive type of argument. The argument that I'd like to push is really that these LLMs are changing our lives in terms of the way we work. And so, in a way, I like to be able to convey to everyone that somehow the way we work is going to change as a result. The way we are consuming a lot of things are going to be changing as a result of these LLMs. And so if you have to make an assessment, it needs to essentially put also in the balance the fact that it provides not just good value, but a systemic information for everyone, not just for the companies and so forth. So in a way, I like to essentially answer your question in a way that essentially is very direct. But I think right now I think a lot of us are excited about LLMs, mostly because they're going to be changing the way we work. That means essentially potentially reducing a lot of our CO2 consumption in different ways that we have not seen yet so far. And so that's where I'm putting myself.
I think Llama 2, the big one, the 7 billion parameter model, total emission was like one back and forth Geneva, New York plane. So that's kind of the emissions of a state-of-the-art large language model. One plane, full of people, of course.
Yeah, so maybe one comment also on this is that, of course, if like people were starting to train these large, many actors were starting to train these large language models. Maybe we could ask this, but it's not really clear that there was going to be so many people like training the very large language models, just because it's not going to be possible. And then the cost of fine tuning these models might decrease over time. I think we're very quick to talk about the use of the energy consumption of AI, and of course we should question this. But I mean, there's a lot of the consumption of energy, like related to, information, which is driven by completely other factors, right? I mean, if we think of just the traffic or the exchange of video content on the internet, this is just massive, right? Comparison.
Let me add one more thing. What we get to see mostly from the open source area is that for the inference, for instance, people are essentially trying to get them on smaller GPUs. And in effect, you get to be able to see that you can run some of these models in int8 as opposed to FP16 type thing. So you essentially reduce tremendously the amount of, or at least divide by 2 somehow, the amount of energy that goes into even producing some results. I think we're just one way into something next that's going to be below int8 in the future. There is also this question how big those things are going to be eventually. And so in a way, we're just our starting moment. And asking to put constraints right now on any of these is a bit like saying, let's not look at what is possible and then eventually do the usual way we've been doing engineering for the past hundreds of years. That is, okay, there is something expensive, a bit like genome sequencing. Cost a few billions back in 2000. Now you can get your genome for less than $1,000 for your own genome. I think once we know what the capabilities are, everything, and we get to be seeing that for the past 2 years, you get to be able to see ingenious ways to essentially reduce that tremendously afterwards. So in a way, I think it's a question, but I think it's like you're asking the wrong question because in 3 years it will be a non-subject.
We are running out of time, so I guess we'll stop here. And unfortunately, we could not deal with all the questions on the app, so sorry for that. We can thank the speaker again, the panelists again. I think that was a very interesting discussion.